All right, hello everyone. Welcome to the Reactor Toronto workshop, all about A/B online metrics. Joining us today is Widad Machmuchi. I'm sorry if I'm pronouncing this wrong. Okay, it's all good. All right, awesome. And she is a principal data science manager in AI platform at Microsoft. She works in the experimentation platform group, and she focuses primarily on A/B experimentation and success measuring. She develops tools and techniques that help teams make data-driven decisions like A/B experimentation, metric development, and user behavior modeling. She also works with a bunch of different teams like Office, Bing, VS Code, and Azure Machine Learning. And she helps apply these techniques to drive user growth. She also has a PhD in theoretical computer science from the University of Washington and is also a co-founder of a technology hardware startup. So a lot of stuff. But thank you so much for joining us, Widad. We're really excited to learn more about you and start the session. For everyone who's on the call right now, the Q&A will be open throughout the call. If you have any questions, please feel free to add them there. We'll either take them all up at the end, or if there's something that's relevant to be taken up during the middle of the session, happy to do that as well. And if you just want to say hi or where you're from, that's cool too. It's all good. We'll also be recording this session, so if you wanted to follow along with anything on your own time later on, I'll post this recording a little bit later on with some links to further content. So without taking up too much of your time, Widad, thank you so much for doing this. I'll mute myself and you can take it from here. Thanks, everyone.
Thanks, Eamon. Welcome, everyone. So today I'll be talking about the importance of proper metric design, and you really can't improve what you don't measure. So this work is a joint work with former and current members of both the Bing Online Metrics team and the experimentation platform team, and I'm really here representing kind of this kind of body of knowledge from everyone. So at Microsoft, in God we trust, but all others must bring data, how Edward Deming said it. So before shipping any change to the product, teams run experiments to really determine the effect of the change and how it will affect the user experience. We believe that understanding what the effect of the product of the change is before shipping it to the product is very important to both capture any unintended consequences, but to also quantify the improvement we're making to the product. And to measure all of these effects of change, we use A/B testing. And once I think, as you guessed from the intro, I spent a lot of time at Bing, so I'll be focusing in this talk on Bing, but the learnings are generalizable to most product. So let's start with kind of some example of what we're trying to really measure here. So what you see here is the Bing search result page, and what we see on the control side, if a user is searching for The Art of War. The Art of War is a book, and we really show the information about the book here on what we call the Taskpane. So you can actually get information about the book itself, and then we give you right down here some resources on where to read this book. What we wanted to introduce to the product is what we call an answer. So in the main result location on the page, instead of having the information about the book only on the right side, we decided to test whether the user would like it more if we have the information about the book there, and particularly where to actually access the book and where to buy it from. So how to read the book. And the question here is, which one is actually kind of better for the user? And in order to determine that, we need to really determine what the intent of the user is when they're actually searching for Art of War. So if you look at the kind of purple arrow, which is the intent is to read the book, on control, it actually, the location is further away from where the user is looking, so the user, it'll take the user a long time to get to that, to be able to know where to read the book. Versus on treatment, this is actually much quicker. It's in the line of sight, so the user will get to that intent faster. However, if the intent is to actually read about the book, and you want to go to the Wikipedia page for it, on control, it's much more accessible because it's the first result page, while on treatment, we actually pushed it down on the page. So it takes longer for the user to get to that intent. And whether treatment is better than control or not actually depends on the popularity of these different intents. So how do we actually determine if treatment is better or not? And that's really where A/B experimentation comes in to help set up the framework for us to establish causality. And then the next step is to create robust online metrics to measure the treatment effects that we intend to see in order to do a better comparison between treatment and control. So before we dig deeper into online metrics themselves, I want to talk a bit more about A/B testing and really introduce it in this just one slide. So the way A/B testing, it's really the simple controlled experiment that we have. You take your user population, you divide it into two products, what we call the control group and the treatment group. The control group will see the existing product as is, while the treatment group will see exactly the existing product with that one change, the feature X that you want to test, and everything else is kept the same so that it's a controlled experiment. Then you track your users for a while, you collect some interactions, and then once you have these interactions, you compute metrics to tell you what the result of the experiment is. Do we believe that treatment is better or not? And then a part of this is that once you collect all of these logs, this is really where metrics come into place. You compute your metrics and you compute your statistical test on them to confirm that the difference are not actually due to chance, but actually can be attributed to the treatment that you're observing, that you're testing. A/B testing is really one of the best scientific methods we have to prove causality. Instead of looking at your metrics and trying to guess what caused your metrics to go up or to go down, A/B testing, because it's a controlled experiment, allows you to be confident that the change you're observing in your metrics is actually due to the treatment and not really due to external factors, that you can be choosy when to follow them and when not to, depending on whether you want your metrics to go up or to go down. Okay, so now that we're kind of more familiar with causality and A/B testing, I want to kind of set up more of how will be some of the concept that we'll be using from online service space and particularly in Bing, so that we'll kind of have a reference point of what are the different entities I'll be talking about. So at Bing, we have what we call the page view, and this is really kind of the system response that we expose to the user. So it can be a search result page. So on Bing.com, if you go and search for Microsoft Reactor, that's really kind of the result page that you see. Maybe on the Windows search box, when you search on Windows, you actually get kind of this different form factor for the results page. So really, it's really any kind of response from the system to some user input that we've had. The second one I want to talk about is any user action. So a user action is really any instrumented interaction that your user has with the system. So it can be a click. So for example, from this result page, if you click on Microsoft Reactor, the click would lead you to what we call the landing page in this case. It can be a hover, it can be some speech input or from the user, for example, if you're talking to Siri or to Cortana, for example. And one other important aspect of this interaction is that you can actually have a lot of properties associated with them. And one of the most important properties that we deal with in kind of the online, when you have kind of an online service, is really what we call the dwell time or the click dwell time. And this is really the time between the click and going back to the search results page. So if I click on Microsoft Reactor and I visit this landing page, the dwell time is really how much time it took from clicking to coming back to Bing again until I see that user in my logs again. And we really think that that's kind of the dwell time of the click. It's a proxy for how much time the user spent on the landing page before they came back to Bing. Another concept here is what we call a session. And while a page view is really an individual interaction with the system, a session is really a grouping of these page views. So at Bing, it's really a group of page views that are separated with at least 30 minutes of idle time. And the reason we use that definition is that it kind of reflects that the user is done with their search intent. So it's a definition of session that's based on this kind of concept of idle time between interactions. You can define this for other services. So kind of it's 30 minutes until you start the next intent, as opposed to grouping kind of page view together based on their properties. It's more of how much time it took the user to come back to the product. So now that we kind of are familiar with these concepts, let's really dig into what is really an online metric. So really what an online metric is you take all the signals that you collect from your experiments. These can be, user interactions, these can be the page views, all of the logs and signals that you collect, and you use them to compute a numerical value that you can compare between treatment and control. And what this kind of value is, you compute it both on treatment and on control. So you get a treatment value and a control value, which are hidden here for confidential reasons. Then you compute the delta, which is really the relative difference between treatment and control. And then you do a hypothesis testing on the delta to really check whether the observed value was simply due to chance or not. So the lower your p-value, the more confident that what you're seeing is actually a treatment effect versus just due to chance, and there's really no treatment effect to detect at all. Really compute many metrics, and I'll cover this more a bit more in this session. You really want many metrics to cover various aspects of your product. So from each experiment, we typically create a scorecard, which is a collection of many metrics of many metrics altogether. And these metrics are meant to really guide you on whether your treatment that you're showing is better for the user or not. That's one point that usually comes up here when I say online metrics and how they are different from offline metrics. So for people familiar with machine learning model or even in more offline metrics for information retrieval, typically there are other metrics that we look at, like precision recall and DCG, which is a information retrieval based metric. The main thing about these metrics is that they're actually based on some ground truth labels that can be generated by judges or by humans or by other means, but they rely on this ground truth label being available. And online metrics, they actually have no ground truth. So that's really one of the aspects of why it means online. Online means we're not really requesting any explicit feedback or any explicit label. It's all implicit based on the user logs that we collect. So the good thing about online metrics is that they actually capture true users' intent, because it's really, we're looking at the user behavior and we're not really asking a judge to kind of put themselves in the user's shoes to try and determine whether this was good or not, which is really what ends up happening with offline metrics, because we're not really asking feedback from the user. While offline metrics they're easier to train on, but they really don't kind of reflect the true user intent and the more of the online aspect of the product. So for example, performance or page load time is not something you can capture with offline metric. This is where you need your online metrics to capture those. So now that we know what online metrics are, for the rest of the talk, I'll be covering kind of three main sections. The first one is, how do you really define robust and sensitive online metrics? And I'll be covering 5 principles to kind of help with the design of online metrics. I'll dedicate some time to talk particularly about success metrics themselves and how to measure user satisfaction in your online product. And then the last point, I'll discuss some more challenges that comes up and fix them overall. So let's get started. So the first design principle for a metric is, what's really the scope of the metric that you're going after. So if we go back to our Bing example, so let's assume you have control and treatment. This is the result page that we're seeing. We have a query and we're showing results for it. So let's assume that our treatment, all it does is that it takes result number 2 without actually changing any UI components to it, just changes the underlying URL for it. So from the user perspective, the result will just look identical between treatment and control. And we really want to see whether this URL is actually better reflects the user intent or not. So one possible metric, reasonable metric to look at here is, we just look at the region that was modified and we just measure clicks on that particular region. So I just measure clicks on result number 2, and that by itself should tell me whether the change that I made was actually good or not, because that's really the only aspect that was changed in the page. So now let's expand this a bit further. Let's assume instead of just focusing on result 2, we kind of rearrange the results on the page. So we switch result 2 and result 3 possibly, and result 4 and result 5. So now the region that we're interested in can no longer be restricted to one result. It has to be the whole result block, because that not only changes the order of the URLs that the user might be interested in, but it also changes the look of the page. So as the user is scanning across all of it, the whole block is actually now different for the user. So really what we want to be measuring is really the click-through rate throughout the whole block altogether. Let's take this a step further. Let's say now we introduce this Taskpane element on the page. And even though we did not really change anything in the results block, but now by introducing that Taskpane, we're shifting the user attention toward a new element of the page. And we might actually start stealing clicks from the result block altogether. So really, the proper way to measure the overall effect is to look at the whole page click-through together and try to understand, did I actually add clicks on the page, or did I just shift clicks from the result block to the Taskpane? And then by looking at the Taskpane, I can see there's more clicks really, but when I look at the whole page, there's no added clicks overall. So the main principle here is that your metric scopes are important, and you really want to create a hierarchy of these metric that covers all of these metric scopes overall. So you can start with user metrics, then you can go to session metrics, you can go to page metrics, and then you can go to feature specific metrics, which is the Taskpane example is from. And the important aspect of this is that as you go down in that hierarchy, you increase the sensitivity of your metric, which is really the ability of the metric to detect changes that you care about, but then they become less applicable to different treatment, as we saw before. So depending on the treatment, you really want to be looking at bigger and bigger scope, because that's how the applicability of metrics work overall. So now that we've talked about the hierarchy of the metrics that we want to look at, let's look at specific type of signals that we care about. So in this example of a treatment, we're trying to see whether we should show the link facebook.com when the user searches for ebook. So in this case, let's assume that the user did not had some typo, or what the search box was not quick in determining in capturing the FAC, and they wanted to go to Facebook, but they end up typing ebook. So if we want to test the value of that treatment and we introduce Facebook as the top result in treatment, a reasonable metric would be to look at clicks, because in order for the user to kind of reflect their intent, they will actually click on Facebook. So if we see more clicks on that top result, we can say that the more clicks we have there, the better it is for the user overall. So the signal we're employing here is clicks, which is one of the main user interactions we have in these online services. So let's look at another example, which is what we call the weather answer. So in this case, what the treatment is doing is when you search for weather on Bing, we actually show you this weather answer. We show you the weather forecast immediately on the page, to where you don't really need to click on the weather channel on this URL to know what the forecast is. It's enough to just get the information that you need from there. So by the design of this feature, we actually don't want the user to click anywhere. We want them to just consume the information as they see it on the SERP, or on the search result search result page. So now that we don't have any user interaction, we don't have any clicks, how can we tell whether the treatment is better than the control for the user or not? So should we say that, if there are no clicks in this case, it's actually good because the user just consumed the information and didn't have to click anywhere? So this is what we call the abandonment problem. And one possible metric we can say, if you have the weather answer on the page and there are no clicks, then this is all great, this is good for the user, let's ship this feature. But what if I showed the wrong location? So for example, I am searching from Redmond, but then I show result from Canada in this case. Or what if the page takes so long to load that the user just doesn't see at all the answer and just completely exits the page because they can't see anything? Maybe there's some error that are being caused by the answer itself. Or even worse, we'd have no weather, the user had no weather intent at all, but we still showed the weather answer. So all of these cases, what our metric will say that the feature is good, but when it actually is not really good for the user. And what's different here is that we're not relying on any input from the user at all, right? We're just saying, if Bing shows the weather answer, then it's good. So that's what we call endogenous signals versus exogenous signals. So endogenous signals are signals that are a direct response from the system. Did we show the weather answer or not? So it's more about how the page looked like and how the system generated that page. While exogenous signals are signals that come from outside the system. They're more user signals like clicks, maybe time spent, a signal from the user as to how they reacted to the page that they're seeing. And really, when you're looking at ship metrics that you want to use to make a ship decision regarding a feature, you really want to have exogenous signals in your metrics, because based on the examples we saw before, if you just rely on the endogenous signal on whether the weather answer showed up or not, it might actually lead you to shipping bad features for the user and not really capture any of those differences overall. So that's the second design principle that we have, is to use exogenous signals in your A/B ship metrics. Now that I've talked about some of these signals, how do we really actually, so I said clicks is a good measure when you're looking at URLs, but how do you define a metric around clicks? And we actually have multiple ways of doing that. So let's look at this example where we shipped what we call the carousel. So if you, for example, search for Morgan Freeman movies, you now see kind of this carousel of movies for Morgan Freeman. And then if you click on any of these tiles, it will open a new search result for you with a specific movie so that you can learn more about it. So we wanted to see what's the impact of that feature on click-based metrics. So are the users clicking more, but also, so this is kind of the effect on clicks, but also how long it's taking the user to click, because we really want the users to get to where they want to go fast. So we want to measure how much effort or how much time it's taking them to click on these tiles. And within those signals, what is the most sensitive and trustworthy metric to capture these effects? So let's look at measuring clicks. This is up here just kind of a reminder of how the timeline looks like. So, you know, you have page views, which are the individual search pages, and then you have a whole session that's a group of page views. So let's look at the first metric. One metric we can compute is how many clicks per page per user did we see. So when we actually ran the experiment and we looked at the delta, we actually saw that these clicks per page per user actually dropped, and the p-value was quite small, which is implying that users are actually clicking less, which is a bit counterintuitive, but you know, that's what the metric is saying. Then we looked at another metric, which is higher scope here, because it's actually looking at clicks per session per user, which is a group of the page views that we see. And actually, when we looked at that metric, we see that actually users are clicking more. So the delta is positive and the p-value is still below our threshold of 0.05. So this was really kind of confusing for us. So we looked at one more metric, which is clicks per user, which is even higher scope because it only looks at the user, kind of at the whole user timeline, all taken together. And we actually look at that one, the metric was not statistically significant at all. So really, how does this make sense? How can we reconcile the difference between these metrics, and how do we actually make sense of them? And the trick here is the denominator of the metric. The denominator of the metric. So if you look at that first clicks per page per user, the denominator is really pages per user. So it's the denominator of that metric. And when we looked at it, we saw that this metric is actually increasing, which makes sense because those clicks on the tiles generate new page views in Bing, and the p-value was below our threshold. So because we have more pages per user, our clicks per pages is actually now lower. And that's really why this metric on its own is misleading. We really want to look at the denominator in order to understand that the denominator is moving, thus causing that top level metric to move. When we look at session per user, it was stable between treatment and control, so there was no denominator movement. So now we can actually trust this metric because it has a stable denominator. For clicks per user, we typically have balanced users between treatment and control. We know that the number of users on the experiment is balanced. So really our clicks per user is always stable. But one thing to illustrate here is that we go back to this concept about scope. As you can see, the sensitivity increase as we go up, but then the applicability and the stability of the metric increase as we go down in this hierarchy. So from user to page to session to page, or increased sensitivity and increased stability as we go from page to session to user overall. So really exposing your denominator as its own metric like we do here is really important to understand those metrics and their movement in the different experiments that you do. Let's move on now to the other signal that we wanted the other metric that we wanted to measure around clicks, which is time to first click. So we computed that same metric on the experiment that I showed, and when we computed the time it took to the first click, we actually didn't see any statistically significant difference at all between treatment and control. To really understand what's going, we actually plotted the distribution of this time-based metric. So as you can see, we kind of plotted how what's kind of the percentage we have for each of the values of the time. So at around like 80% of all the instances that we looked at had time below than 1 minute. But then there's this long tail of values that really causes the average of the metric to really be quite large. And this long tail, because it leads to a large average and a large variance, it actually significantly reduces the sensitivity of the time to first click metric. And that's why we don't really detect any statistically significant difference between treatment and control. So one of the things that we can apply here is what we call capping, which means instead of recording these values as they are, we cap the value at a certain threshold. So here we tried both 300 seconds and 60 seconds. So either capping at that 60-second mark or capping at that 5-minute mark. And what we actually see is that there's a big increase in sensitivity when we do that, right? Like the p-value is dropping significantly from the first metric. And that really tells us that by capping, we reduce the variance of the metric and hence increase the sensitivity in detecting changes. There are also another way to actually increase that sensitivity a bit more, which is applying transformations. So one of the transformations we apply is usually the log function. And as you can see, the sensitivity even increased more when we applied the log function. So what's really the trade-off between all of these transformations, and why would we go for one versus the other? So when we look at the plain value of the metric, the good thing about it is that it's unchanged, it's still very interpretable, but the problem with time-based metric is that they are insensitive due to that long tail in the distribution. When we truncate, we still have the unit unchanged, we gain sensitivity, but we might be blind to some effects. So if we truncate at 60 seconds, we really, any change that happens in that long tail, we now are not able to detect it. With the functional transformation, we really get a lot of increase in sensitivity, but the problem is the unit is meaningless now. And you can actually see it here. Originally, we were dealing with like 15–20% delta, but now by applying the log, we really changed the unit, and it's really harder to interpret what this 5% mean now. So to summarize, these are the principles that we have for defining robust and sensitive online metrics. You should have different scopes of your metric. You should rely on exogenous signals for your shift metrics, and always expose your denominator. Sometimes the metrics are invalid if the denominator moves. In terms of sensitivity, the smaller the scope of the metric, the higher its sensitivity. And in order to increase the metric sensitivity overall, you can apply truncation or these functional transforms that I showed before to increase the sensitivity of your metric and reduce the variance. So now we have these principles for defining robust and sensitive metrics. So how can we actually apply these techniques to build a class of metric or a set of metrics that can cover all the aspects of our product? So what we've found is that you need to have metrics around various aspects of the product. So the first thing you want to measure is these system health metrics. So this is things like page load time, error counts, or no results page. And these are really the metrics that kind of rely heavily on these endogenous signals that are just really the system response. The second set of metrics you want to have are engagement metrics. So this is really how many searches did the user do, page click rate, abandonment rate, how much did the user engage with your product overall. But not all engagement is created equal, right? Not all clicks are the same. Maybe the user clicks somewhere and then go back directly from that landing page, which is usually an indication of dissatisfaction. So that's why the other class of metrics that we want to look into is what we call success metrics. And what these success metrics do is that they qualify the engagement signal so that you can have more of a classification of this being as satisfaction or dissatisfaction for the user. So for example, the time you spend after a click, if it's a short time, in the search world, it actually reflects dissatisfaction. Well, if it's longer time, then it satisfies satisfaction. Let's say you do a follow-on search. So if you reformulate the previous search, one example would be you search for like Pizza Hut, but then the next thing you search for, or the user searches for, is Pizza Hut Seattle. This tells us that the user was looking for a specific location and they did not find it. So this is what we call the reformulation of the previous search or the reformulation of the intent, and that's usually associated with dissatisfaction. So I want to spend some time talking about some of the kind of efforts that we've had in creating user satisfaction metrics and how they actually capture like a user, how we can actually kind of use it in our A/B test to really measure whether the user was satisfied with what we're showing them or not. So going a bit back onto when we talked about page views and session, the way we really look at a user timeline on Bing is that this kind of list of events. These events can be a query, which is a search, a reformulation, like I explained before, maybe a click. So it's really a collection of queries and clicks that the user is interacting with over in the session, and then eventually they leave Bing because they were done with their session. So what we do for user satisfaction is that based on that timeline, we compute what we call a utility. And what the utility does is it kind of looks at every interaction and tries to determine, is that interaction giving the user something that they want, or is it taking away something that they need? So the way the classification here works, and this is mostly applicable in the search setting, is that when you search for a term and you're just spending time on your page until you find the URL you want to click on, this is what we call negative time. You're just spending time looking for information. Once you click on the URL you want to read, this is now a time that you're consuming information, and that's really what your intent is from a search engine, is to find information you want to consume. So we kind of do similar treatment for the various events that we have and the various interactions that the user has with the search engine. And then over time, we build what we call this utility. So the user, because it was a negative time here, the user starts with negative utility. And then as you know, they read they went to the page they wanted, they spent positive time on it. So now this actually becomes positive time because we're kind of really adding up the contribution of these two squares that you see here. The user struggles a little bit more, and then they eventually end their note on a high, end their session on a high note, because they eventually end up getting to a page where they were just consuming the information that they need. So while this is showing kind of this utility framework for Bing specifically, but it's really applicable to any kind of user interaction product that you have, where you can view your session, the user session, as a time-ordered list of events, and then each one of those events can either have a positive or a negative weight, depend on whether it gives user utility or the user is gaining something from it, or they're actually expending something from it. And this really gaining and expensing is really what this payout is. For a search engine, it's really kind of the time that the user is spending overall. And you know, if the user lands on a page they don't like, we count this as negative time. If it's landing on a page that they like, this is actually positive time. So this really allows us to really, as the user is spending more time on the search engine, to know whether to kind of add up the contribution of these different times and know what time is positive and what time is negative for them. And because we're kind of building this utility over the session, we really want to make sure that you know, we're normalizing by time, so that we kind of get this concept of a utility rate, which is a user utility per second. So this is really just adding up all the contribution from the different events and then dividing by normalizing by the payout you get from this session. And this really reflects how much utility the user has over time in the product. One component here that I talk about is kind of these weights, and they can be kind of a bit fuzzy to determine. But some of the things that we try here for these weights is to kind of we have a data set of anonymized user timelines with labels that we've kind of we've asked human judges to label. So this is where ground truth come back again, where we can leverage these ground truth labels to really determine what the weights of these events that we're looking at are. Another way is what we call running degradation experiments to really better understand your metrics. One of the kind of famous experiments that they've run in this space, whether Bing has done that, Amazon has done that, is you kind of on purpose slow down the page a little bit to really understand what the effect is on your metrics, to make sure that your metrics are actually capturing any of the negative aspects that can be introduced accidentally. So by intentionally slowing down the page, you test that your metrics are actually capturing those negative intent, and you can use that to determine the weight of such of these user interaction and events overall. One other thing I want to mention about our success and satisfaction metrics is that they really need to be a continuous update of them. They need to reflect the business needs. They need to reflect any new canvases that the product has. They maybe better understanding of user behavior. Like every metric is flawed, and you really need to keep updating it to reflect what's the to reflect the business need and the current way we're trying to address user intents from the product. So continuously updating your metrics and examining them is super important. So I hope this kind of gave you a quick view of how to really create your metrics and kind of this different hierarchy going all the way up to success metrics. But then all of these come with their own challenges. So I'll spend some time going through some of the issues that come up and how we can actually work around them overall. So the first, these are the three issues I wanted to talk about. And the first one is really validating metrics. So how can we tell that our metrics are actually pointing in the correct decision for the product? Because what we're doing here is we're running an experiment, looking at our metrics, and if they if they show that this is desirable, we ship it. If they show it's not desirable, maybe we'll iterate on it until we find what's actually making it undesirable. So how can we validate these metrics? And of course, the answer is more data. So based on so I touched a bit on this before, but there's this concept of a flight corpus or an experiment corpus where all of these A/B experiments that you run, that you learn something from them. So you can actually, let's say one example I gave before is a degradation experiment, where like if you slow down the page, knowing what the intent of what the effect it has on the metrics. So having this collection of experiments that whether they're good or bad for the user, and evaluate your new metrics against this set of experiments is very important. And that's really how you validate that your metric is still telling you the right story. So as you're building your experimentation platform, keeping in mind this kind of building a kind of a corpus of experiments will be very useful for you to validate your metrics. Another one is a kind of page level ground truth data, like I showed before for the weights. You can kind of optimize some of your metrics based on these ground truth data, but it's usually not a good guarantee that the metrics will work well when you do that in an A/B experiment, simply because they're not optimized in an online setting. So they can point you in the right direction, but they're not necessarily the way to do this. The best way to start is to really kind of build this corpus of experiments that you have. I want to talk about is kind of insensitivity to low coverage features. So one example that I've talked about is the weather answer earlier, and not all queries will show the weather answer for you. Like the query Microsoft Reactor should not show that for you. So really what we want to do is to be able to identify the affected page views exactly. So when I talked about kind of introducing the book buying feature, not all searches will show that features, and we really want to be able to zoom in onto that onto the queries that show that feature, because the page views that are unaffected by the treatment simply add noise in online metrics. Like so that's how we introduce this concept of a triggering or triggered page. So a triggered page is where the feature being tested can actually affect the user experience on the system. So sometimes the feature will not show up for all queries. One example, this is the example here, is like the book buying feature will show up for Art of War, but will not show up for Microsoft Reactor. So that's really what a triggered page is, but we really want to be able to identify them correctly in treatment and control. So if we go back to the book buying feature that we have here, on treatment, it's relatively easy to find what the what the affected query is. Did the answer show up? Did that feature show up on the page? It did show up. So then this is the triggered page. However, on control, there is no feature that showed up. So how can I know that this this query or this page would have been affected by the treatment, or would have shown the feature if this ended up being on treatment? So this is what we call the counterfactual logging. So with counterfactual logging, what you want to do is, for every request that comes, so typically, let's say you have a user request from treatment, you go through kind of the treatment system response, and then you show the user what you want to show, and you store some logs, some data in the logs. But in order to really know whether this was affected by treatment or not, what you want to do is, in parallel, run it through the control system response and test whether the responses are different. And if they are different, then I set this counterfactual flag to 1. But I show the user the response that's coming from treatment. For users on control, I'll do the same, but I'll show them the response coming from the control user. So what I will do here is we'll also test whether the response is different and set the counterfactual flag accordingly for that. So I'll run both responses, but show the user the one coming from control and store the counterfactual flag accordingly. So what counterfactual logging does is it'll automatically tell you this request or this page view was affected while this one was not. And I have that flag in the log, so all I need to do is just filter down on that flag to really understand the effect that the feature had on the users, and ignore all the other pages that were not affected overall. So that's what I just said. So when you're designing your counterfactual, there are kind of a few things to keep in mind. You really want to be running this counterfactual in real time, because there are multiple factors that can affect it. And the counterfactual need to be very accurate. So you really want to detect all the pages that are affected and not miss any of them. Because if you have a low recall, your analysis is missing some important affected pages, and by not having them, you're biasing your measurement, the measurement that you have. Low precision is a problem, but not as much of a problem. It's a problem in the sense that it will increase noise in your measurement, but the counterfactual itself is still valid. And as you saw from before, the counterfactual logging can increase computation. Can increase computation overall, because you need to run both control and treatment responses in order to compute that counterfactual flag. So really, you want to do a trade-off here between a slower user experience and increased metric sensitivity. And once you have that counterfactual flag, how do you actually analyze your logs to get to be able to zoom in on your on these triggered pages? So if the triggered page here is showing up for user B only as these like red dashes, what we have is what we call the user triggered analysis. So we only filter the user that actually had these triggered page views, and we analyze their logs only in the metric, ignoring user A, which actually was not affected at all by the feature itself. And just here a quick example of how much increased sensitivity you get. So this is just one example of a scorecard we have where the standard, or we didn't do any filtering, all the p-values for the metric are actually quite high. But once we filter down to the proportion of the users that are actually triggered, you can actually see an increase in the sensitivity for some of these metrics overall. For the interest in time, I'll go through this quickly. So this is just one technique to make sure that your counterfactual flag is correct. This is what we call the user triggered complement analysis. So you still compute a scorecard on the users you excluded to make sure that there is no treatment effect at all in that scorecard or in that analysis, and that verifies that your triggered condition is actually correct. The last issue I want to talk about is kind of the selection bias when reporting metric gains from A/B experiments. So what happens is, you have all of these experiments that you want to run, that the team wants to run. They want to experiment possibly with 10 similar variants of the same technique, and they want to ship the technique with the largest metric gain because, the metric is pointing to the right direction. However, and you want to kind of reflect that metric gains for them and track it for their commitment that they improved the user experience with whatever metric gain that they had. But however, experimentation itself has some randomness. So if we assume that the metric gain is has this normal distribution, if you keep running the same test over and over again, even if your all of the gain is actually centered around 0, we can be selective in what we choose and choose this one, the one that has the highest gain overall. And this actually leads to bias. So you don't really want to just pick the best experiment. That's what goes into p-value hacking, or having bias where you keep testing and testing until you get a result that's being static. So really, you want to have a system around this to reduce that selection bias overall. And that's what we call the certification process. So having a very clear process around how do you choose which which features to ship. So you have this notification of intent. Okay, I'm actually interested in shipping this feature. I made the ship decision based on a previous experiment that I've run, and then we rerun this experiment to make sure that there's no pre-experiment bias. The users are all balanced, and we get this reproducibility of the gain that confirms that, or is actually one of the best ways of reducing the bias, the selection bias in these experiments. So by reproducing results, you reduce this slicing and dicing of the data or of the experiment that would lead you to just ship something with the highest gain that happened due to chance only, but not really reflect a proper improvement of the product. So that was the last of the issues I wanted to cover. Thank you for listening. And this is some resources for us. This is my LinkedIn page and and my page on MSR. Over there, we have some more blog posts and more papers around the topic from my team, from the experimentation platform. And feel free to reach out if you have any questions. Thank you.
Thank you, Widad. I see that there's still quite a few folks on the line, so if anyone has any questions, please feel free to add them to the chat, and we can take them up in the last 10 minutes of this call. And if not, then we'll just give a couple minutes to see if anyone has any. And if not, then we can end a little bit early. So I'll just give it a couple minutes to see if any questions come through. Yep, I see one. Oh, we got a compliment. They said, excellent presentation. So thank you so much for that. Let's see. Okay, doesn't look like people have any questions. If there are any other questions that come through, please post them in the meetup group for this, and I'll send them over to Widad after, if that's okay with you, Widad.
Yeah. And please feel free to reach out directly on LinkedIn. I'm happy to point you to more resources or answer any questions that come up.
Awesome. So on that note, I've placed a survey link in the chat, and it would be much appreciated if you guys could give some feedback. Oh, and there's another comment. We got someone saying it's very insightful, the topic that you delivered, so that's great. But yeah, so the survey link is posted and there's a code there as well. Your feedback will help us improve presentations and do more stuff like this, and great for Widad to know as well for how, when she's delivering content, so much appreciated. And on that note, thank you so much for joining us. Thank you, Widad, for your awesome presentation. Clearly, it's very appreciated, and we'll get in touch with you soon. So the YouTube link for today's presentation will go up in about 2 or 3 days. And then in the meantime, feel free to reach out to any of us on social media. Thank you.
Thank you. Thanks, everyone.
Bye.